Okay, so session is being recorded. Let's get started. And before I introduce Bimo, I want to tell the students that if you have any, I won't be able to respond to all your thing. So what happens is, if you have later on during the sharing and after the sharing, if you have anything you want to ask Mr. Bimo, you can WhatsApp me, and then I will through the WhatsApp. Okay, if you're unable to write on the chat, but as long as you can hear us and see us loud and clear, that should be fine. Okay, so we're gonna start now. Okay, so I'm gonna introduce Mr. Bimo. I didn't even get the chance to ask you if this is the right way to pronounce your name, Bimo Adi Prakoso. Is that correct?
Correct.
Okay. So Mr. Bimo is from Indonesia, and yeah, I think he is a. Wait, I got my. Everything is so confusing right now. I have your introduction written somewhere, but I lost it. So I'm just gonna have to search for it. Search for it properly. Just give me a second.
No worries.
Yep. Okay. I would like to introduce you properly. Okay. Yes, Mr. Bimo is the founder and chief trainer of young engineers and scientists, and also he's going to give a sharing on aeronautics and designing compact, short, medium range UAV and UAS airframe. So his experience also include 3D modeling, animation, visual effects, nonlinear editing, and much more. But I think overall, I want to introduce you as Tony Stark, because to me, I really believe that somewhere right now you are designing your own Iron Man armor somewhere. So I think you can also share that with the students. So without much further ado, I will pass the stage to Mr. Bimo.
Okay, thank you so much, John, for the introduction. Good morning, everyone. It's pretty much very honored to meet you all, right? Even though that I couldn't see you each because the video, I don't know, video and audio seems don't work at this stage, but I think John worked it out so we can somehow continue the session. Okay, so I'm gonna start sharing my screen right now. Hang on. John, kindly let me know if you can see my screen at the moment.
Yep.
Okay.
Currently, yep, we can see it.
Okay. Okay, awesome. Right. So let's begin then.
Okay.
Okay, so I thank you guys for attending this awesome meeting, although that we have some small technical difficulties, but John actually made it work, right? I'd like to thank International University and College, especially Diploma in Interactive Multimedia with Animation Design. Also, my colleague, John. It's a great honor to actually be here with you guys all, okay? And good morning to you all, right? Okay, to begin with, actually, I would start with a very simple sort of a sentence here, right? So it's actually a question. What do you think schools did to you after you spent dozens of years attending? Okay. Frankly speaking, this came across my mind, I don't know, many years ago, but I think I have the answer right now, right? After actually carrying along with my personal journey up to this stage, okay? So without further ado, I think we could somehow answer this question in the end of the presentation. So again, right now, I will personally introduce myself, right? So John mentioned my name already. My complete name is Bimo Adi Prakoso, and so fortunate that I already have 25 years of experience right now. I'm the founder of Flies International, a non-profit organization. Consists of 3 founders. Me, my colleague Jeff Reimer in Canada. He's a former sort of a NASCAR racer, and Jim Soyak, former USV officers, right? And during my 25 years, I was actually graduated from mechanical engineering department in one of private university in Jakarta. Okay, and interesting that I've been teaching and lecturing for about 25 years as well. Okay, and then I'm also a business executive in some companies too. Joined several companies a couple of years ago, and up until now, and I've been actively active in marketing activities and creating brandings as well. And I have sort of personal experience in broadcast multimedia animation and visual effects, as well as digital security for content delivery, telecommunication industry, and all my passion in product development and design engineering. So designing digital objects and content has been some of my primary passion since early 90s, right? So I was actually asked by John to actually share my experience here. So it's personally quite interesting for me, personally, especially journey as an aerial platform designer. Okay, particularly I'm specifically a fixed wing designer, so no multi-rotors, no drones, especially for fixed wing aerial platform. That gave me so much interest since I was in school. Okay, so this is actually my biggest milestone, right? I'm the author of Autodesk Smartbox Shortcuts, and it was published back in 2009. And the book received an honorable acknowledgement from Oscar 2007 nominee for visual effects supervisor, Boyd Shermis. So it was so unbelievable once I actually wrote the book and received such acknowledgement from this very super guy. He's also my mentor as well for visual effects. So designing unmanned aerial vehicle, right? So how did this into me, right? I may say a common phrase that you might already hear before. For those who have big dreams, just hold on to it, right? Because big things were often started with small things. And the toughest challenge may not be related to how big is the dream for us to make it real, but how do we start the dreams with something simple? Right? So start something simple and then just enjoy the journey, okay? So this guy is actually who somehow inspired me and inspired millions of people in the RC planes or this kind of hobby, right? His name is Dave Powers. He's the inventor of score and fold approach in creating RC planes. So he took the different path anyone who created or do it yourself RC planes. So he invented the score and fold approach by himself and his partner as well, Scott Lott, with all the difficulties in the beginning, but he succeeded. He succeeded very well. He's well known right now globally, but he had retired from RC plane probably about 2 years ago, right? So leaving his legacy to millions of builders in the world. But I knew him since 2014. So he actually caught some difficulties to continue designing RC planes because the advancements of the technology softwares, it's now beyond my expectation, even just about a few years back, right? So it took him about 3 months to do each plane. Some planes actually are listed on top of the slide: SU-30, SU-34, F-18, and X-29, right? And some more, okay? But he's combining pen, papers, rulers, as well as some type of common CAD software like AutoCAD, right? But when he tried to somehow explore to have sort of a much more details, pen, papers, and rulers would somehow be his obstacles. So he decided to retire from the RC plane designing about 2 years ago. And only few designers in the world right now carries the score and fold approach for creating RC planes. I could say that Jay Rothwell, okay, Dave Powers himself, Scott Lott, Jay Rothwell, Stefan Moran, and Bob Darrenault, and the last one is me. So only less than 10 people actually continuing to design with score and fold approach. Okay, move on to the next slide. So what score and fold RC design is, right? It's pretty much like origami of RC plane. We started with very flat Teflon, 5 to 6 millimeter Teflon sheets, right? And we form it into 3D fuselage without any sandings because we try to copy how the origami the objects, right? With origami, you can have a piece of paper or some more pieces of papers. Then you just fold it, right? But in this Teflon 5 millimeter or 6 millimeter thickness of Teflon, you cannot just simply fold it. It will easily snap, right? So what you do is actually you place a tape, right, on the bottom, the other side of the surface, and then you score instead of cutting through, but you just score and you just fold it. You fold the sheet and try to form from, okay, this on the third slide on the upper pictures, right, the top pictures. The third slide, we have a flat sheet cut with a pattern, particular pattern from the design, right? So just below the picture here, you can see that this flat sheet is forming actually the top fuselage, right? So this is very interesting and it's a bit challenging. But once it's done, you can see the rest of the pictures on the left side before it got painted and after it got painted. So it's very, very interesting. So this approach is called scoring for RC plane scratch build. Okay, so we need somehow to move it a bit faster because we lost minutes in the early time. So how do we initiate the design process, right? How do we initiate it? And most of all, we start with many questions before we got into the idea. Questions is, how do I get started, right? So I need somehow to go to this hobby, right? RC plane hobby before designing anything. But after jumping into the hobby, I need somehow to know more, right? So I wanted to somehow to be involved in designing the RC plane. So I started the design process with the questions: which software do I use, right? So how to model and match the scale, that's important because when you try to somehow copy a plane, a jet, or any kind of objects, right? You need somehow to know sort of the dimensions, right? So how big the plane should be. Bigger plane, it will somehow be harder to transport, right? So how do I know the calculations required to design a plane? It's also pretty challenging, but much information actually I can somehow share you a bit after this slide, okay? So how rigid will the model be? Because the airplane, the RC plane with fold is actually created with very fragile Teflon sheets, which only have about 5 millimeters or 6 millimeters thickness, right? Will it fly nice? So those are the questions for me in the beginning. Those were simply very, very broad to answer. So I urged myself to leave all the intimidating questions out of my door and started with basic things. I need to know how simple aircraft design process works. That's it, okay? So after a while, getting the idea out, right? Um, hang on, mouse. Okay, mouse is working again. So after getting the idea, I need somehow to go for research to look for some information and examples on the web, right? After getting it out, I need somehow to compare and analyze, okay? In order to define my own requirements for the plan to begin the design process. Pretty much like doing reverse engineering with the comparing and analyzing some designs over the web, right? And also comparing with the real plane. After completing that, I define my requirements to design my plane, and then plan it at early stage. But this will somehow still be missing some information. So again, I look for some more information again on the web, and this could somehow build my confidence in actually going forward with my plan, with my design. And then after all completed, design had been made, I needed to build my prototype. Okay, so fortunate that I have two colleagues outside, one in United States and one in Canada. So both are very, very kind, and they have been helping me a lot. I mean, with the research, with the prototypes. So after we built our prototype, we review the prototype and try to make some notes. Should there be any changes, adjustments, additional details, and so on. Okay. So once the process is completed, we need somehow to actually pack it down and try to go practical. Why? I learned something very, very important, that if we somehow could simplify things, then we really understand the things that we're working on, right? But if we couldn't, we still haven't got any sufficient knowledge to about the things that we are working on. So, project preparation. I don't know, have you ever lost your motivation when in somehow trying to do things in the first time or in earlier stage, right? So as for project preparation, you need somehow to get yourself motivated, okay? I started to design a plane that I'd love to look at and build, as well as flying it, okay? So I don't like all planes, so I have my own preferences. The Sukhoi 30 SM is actually one of those. I don't listen to other people when I try to design it first time, okay? Why? I need to satisfy myself during my learning process. And this is very important because I could keep and maintain my motivation at the highest level instead of placing efforts and trying to make other people happy, right? Don't get me wrong. Once the knowledge is obtained through the process, you could do whatever you want to do, including make other people happy. So that's actually an important thing for me. Okay, so looking for some reference, actually it's an easy task to do from the internet right now. We have search engines, we could somehow look for pictures, we could look for auto drawings, layout drawings, right? So for example here, I actually downloaded the drawing from DeviantArt website, right? I love Sukhoi 30 SM. Is actually up until now my best design ever, and it's been, I don't know, probably about 3 years in a row. Nothing could somehow put it away from the place right now, because it's been sort of appointed as community favorite design, right? So we can somehow get many references through the internet. And then another thing is that we could somehow get equations, mathematics equations. So how many of you somehow get, I don't know, probably intimidated with this? So math is our daily subject, but not with the equations. Okay, let me somehow concentrate on this later on. Okay, so the next one is actually two. Come on, my mouse is not working again. Okay, that's it. Choosing the 3D software. So fortunate that my company is one of the distribution partner for Rhinoceros. So I just simply get Rhinoceros for my main design purpose software. So for my hobby, for work, designing unmanned aerial vehicle or aerial platform, for commercial as well as for military purposes, Rhino has been somehow doing the work for me very, 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 very well. But don't get me wrong, there are various. I mean, there are various software available out there, whether it's free or commercial. You have SketchUp, you have DraftSight, you have Blender, and for commercial, you have Cadia, you have SolidWorks, you have Fusion 360, and PTC. Any other software will somehow work. Just pick that suits you and enjoy the journey. Okay. So back to these equations. Don't get intimidated with this. Okay, there are many online resources available on the net. Okay, such as rcplanes.online. They have what they call it online calculator to actually define center of gravity. Okay, this is very, very important, because if you couldn't somehow define center of gravity properly, any plane would not somehow be able to fly. So any anything with wings, anything with body, with also proper center of gravity, it will fly. It will fly. So if you have much like a pencil or a pen, right, and you create or design a wing for it, and you define the center of gravity, and you launch it, it will fly. It will fly, right? So don't get intimidated with equations. There are a lot of equations I got from NASA journal or DARPA or published books. But to begin with, this source is enough because it has online calculator and you don't have somehow to get confused with many parameters. Okay. So in designing plane, we need somehow to put common sense in it as well. And what are the common senses, right? Okay. In order to define the size of structural design of this, okay, let me show you the SU-30SM, for example, right? I also place some considerations into the design with that will minimize any potential issues such as, okay, the wing won't fit the plane size, the wing size won't fit the Teflon sheet. That will somehow be an issue because largest Teflon sheet available is about A0 paper size, right? About 1100 by 800 something. Okay, 1100 by 800 something. If it's too big, then you will have somehow difficulties to actually cut the panels and construct the planes. Okay, it's too small to construct and too big to construct. Another issue, right? Or once it's done, once it's constructed, it simply won't fit a normal car for transport. So that, what's the point of building large planes when you couldn't somehow bring it to your flying field? That's an issue, right? So based on my personal experience, I mostly design my plane with 700 millimeters wingspan, right? So that's the first parameter that I use in order to create or to design a plane. So the wingspan is between 750 millimeters up to 800, or the most 850 millimeters. Okay, so dimensions matter. Okay, the next one, parts used. Which battery? Is it 3 cell, 3 cells, 4 cells, how much capacity in it. The capacity defines the weight of the battery itself. So normal battery I use is 1800 milliamp per hour, but there are also available around 200 to 200 milliamps hour, 3500 as well. Picking the small or even smaller battery capacity when you try to somehow pick the center of gravity after you calculated it. Okay, motor, high speed motor, low speed motor, high thrust, high power motor, servos, digital, analog, electronic speed controllers, transmitters. Transmitter somehow it's the TX, right? Transmitter that will somehow control many things on the plane. If you need to design a casual plane, you won't need more than 6 channels. Okay, but if you want to have more control surfaces, more electronics, you need somehow to have 8, 10, or even 16 channels of transmitter. Tools and materials, of course, you need Teflon sheets, you need cutter, you need cutting mat, you need glue, you need steel wire for control rod, right? Polymer sheet, and everything, as well as the plan. Once you actually create it, or once you generate the plan, you need somehow to print it out and then place it on the Teflon sheet. It will somehow become the pattern and show you the guidance when you cut the materials. The design output. Okay, after you define the electronics, the components, and cutting the materials, right? Before that phase, during the design process, using the computer when you design it, right? We need somehow to have, you define that you need to have Teflon RC plane design, right? You can somehow create the 3D model inside the software, okay? And it needs to consist of 2 things. First, the shells, right? The surface, the outer surface of the plane, and the inner structures. Why? In order somehow to design a very good plane, you need somehow to have good and sufficient structures as well inside the plane. It will somehow keep holding the plane intact. Weak structures, it will somehow endanger you or probably other people when you're trying to fly the plane. And weak structure could somehow possibly lead to a plane to fall apart while flying. So this is actually very important. Okay, so after you design the shells, after you design the structures, then another optional way to actually know further about this plane is actually to simulate it. Okay, if any of you have ever heard about CFD, computational fluid dynamics simulation, right? It's pretty much like having a virtual wind tunnel inside the computer, okay, inside the computer. So with CFD software, we could somehow try and define and look sort of a prediction of how it will fly. With all up white, with the design, we could somehow know the lift, we could know the drag, right? Most parameters we could somehow address in the CFD simulation. Commercial CFD simulations tend to have big price. I mean, big price, like about a couple of thousands of dollars. So I don't know, tens of thousands of dollars, right? But there is one very good CFD simulation software called OpenFOAM. It's free. It does the job well. So I've been using OpenFOAM for my main design requirements, and it answers all the challenges that I needed very well. So I recommend for you guys to actually look for OpenFOAM. It's Open FOAM, right? It's free. You can simply download it, and the visual visual programming is also available as a Power View. So after we simulate, we actually come up to sort of a design that we will create. Okay, so this is actually the SU30SM design, 3D design in score and fold in rhinoceros, right? It had been through the CFD simulation with OpenFOAM. So this is actually the final design. But before I somehow go with this, again, I need somehow to mention that if you're convenient with Blender, if you're convenient with SketchUp, if you're convenient with other software, just go with it, right? If you would like somehow to go higher than that, I mean, sort of a commercial things, just go with commercial. Then you need somehow to go with commercial choices like SolidWorks, PTC, Rhinoceros, or some other softwares. But there are many people out there have been successfully creating RC planes using Blender and SketchUp. Those two primary free softwares are available for everyone to actually download and access it, and it's pretty powerful. But I somehow encountered few sort of requirements that they couldn't help meet my personal requirements, not other people. So I chose Rhinoceros actually to go, and we could somehow look for the live presentation with Rhino here right now. Okay, let me somehow open, oops, sorry, Rhino, there you go. So John, can you see my Rhino screen at the moment?
Yes. Yep.
Okay.
Clear.
Awesome.
Yep.
Awesome. So this is the SU30SM, as you see, right? If we somehow see it with X-ray viewport, whoa, see? The structures, the tabs, the registers, it's there, right? Okay, here. Okay. Let me just ungroup this first. Okay. This is kind of the internal view of the structures. You need to have registers to actually align the panels onto other surface, right? So this is actually the process of how I created the design. So instead of actually showing it one by one, at the moment we don't have much time to do it. I need somehow to show you this, right? So John?
Yeah.
Okay. So are the students familiar with 3D softwares? I believe that they are, right?
They have, but not Rhino. And OpenFOAM, just now you mentioned OpenFOAM is also a 3D software, right?
OpenFOAM is actually a computational fluid dynamic software. It's not 3D software actually. Right. It's meant for simulating, right? Fluid, airflow, any kind of fluid dynamics. They could somehow be simulated in it. It's quite a resourceful, right? But it's free.
Which means that you can model something in Rhino and then bring it into OpenFOAM and to create a simulation.
Exactly. Yeah.
All right.
Okay. So with this, okay, let me show you, right? So what I'm going to do is actually try to begin with the very simple process, the scale, right? The scale. I need somehow to have exact scale of a model which carries 750 millimeters wingspan. So I just copy this. There, right? So I'm going to have exactly 750 millimeters, 750. Okay, next point. That's 750. But when I somehow drop the picture, it wouldn't automatically be 750 millimeters. I need somehow to adjust this. So I align this first. Orient. Okay. This. And this to this 750 millimeters of hang on, this is okay. Not track. Okay. Here, endpoint near intersection perpendicular. Okay. This. Oh, sorry. Hang on. I did it wrong. Reference 1 here. Reference point 2 here. Okay, I need somehow to have exactly 750 here, here, and then scale it. Okay. See, it's scaling up following the reference. So I would like somehow to make it exactly 750 millimeters wide of wingspan. There you go. So if I click this and analyze how long is it, so length is exactly on top of this 7 on top. The right, sorry, left, upper left set. It says 750 millimeters. Okay. So this is actually the size that I want to actually have the plane to design. So I match for other view as well, this one. Okay. So after matching it, I begin with, I don't know, probably the wing or the canopy or something else. But here, I'm going to show you guys how to actually create the canopy. It's actually pretty simple. You go with other view. Hang on. There we go. Here. Start with line. Okay. Disabling it, the starting here, probably, and here, 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 and here. Okay. That's the first one. I need somehow to lock this. So I couldn't somehow accidentally choose that. Okay. This, we need somehow just to move it a little bit, and we could somehow also see the reference up here, right here, right? Okay. And then we create another one from here. Okay. Enabling the object snap again. Project 1, 2, 3, 4. Okay. Oops, sorry, I actually missed the, oh, I select the wrong one. Okay, should somehow be here, 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 and the last one is there. Okay, no worries with this. So activate the sub objects, drag it here, right, and adjust point accordingly. Okay. since we're using about 5 to 6 millimeter depron, so why not somehow I actually align the position of the point or the lines exactly at the end of this guidance for the canopy, because it will somehow carry about it has 5 millimeter thickness, right? So if we somehow have a surface on top of this, so it will have additional 5 millimeters. So I need somehow to reduce or put it away the lines and points and reference about 5 to 6 millimeters, right? It's not exactly though, but it will somehow help to actually maintain the shape of the plane once it's been constructed with 5 or 6 millimeter paper sheets. Okay, with this done, okay, I just simply copy the other, this first line here. Just simply, we can do it mirror, okay, very old-fashioned way, like that, okay, and then create a surface here using a surface tool, like that, and then here and here, curve, create another surface, okay, and then here we could just simply select these two and then extrude it accordingly. So we will give a shell like that, with 5. I mostly create 5.6 millimeter thickness of the sheet, because when I couldn't somehow find 5 millimeter depron and only 6 millimeter available, this 5.6 is actually matching between the 5 and 6. Okay, so I'm using 5.6 millimeters. Okay, that'll do. Select this and select mirror again. Okay, so we have three already panels to actually begin with. Okay, since it's constructed from very thin depron sheets, we need somehow to put it into convert it into a layout plan, right? So I just select these panels, copy it, right? Paste it, drag it here, pretty much this example, okay? And then what would I do? Simply explode it and select each, this, and this, and this, and put them together again. Okay. Select it. Oh, sorry. This should somehow be adjusted as well. Okay. This, and this. One very useful feature is in Rhino is actually unroll the surface. So this is actually the surface that we would like somehow to put as a plan. Okay. Okay, this one. Okay. Just roll. Sorry, unroll. Explode, no. Labels property, yes. So I set all these options to this standardized options that I mostly use to explode, to unroll this. So I just execute. And this is actually the canopy. It's pretty much like a flattened origami object, a box or a bird or something else, right? And we could just unexplode this and have different. So we need somehow to orient each panel first. Here, replace here. Okay. Or here, we could just somehow union this, right? Or join those, and then again orient it here. or we can somehow this and this, okay, and orient them like this. Why? Because it's much easier somehow to actually cut panels, right? These two particular lines will somehow be cut as score, not cut, right? So I will score this and place tape below the surface of these two panels, in between two panels there, because I need somehow to fold it, right? So once the design is complete, okay, this, join or group, whatever, okay, I could just simply extract the wireframe. Extract the wireframe here. Oh, sorry, I need somehow to all of them. Extract wireframe. There you go. Okay. So I will somehow remove any not useless lines. Yes. Oh, sorry. Yes.
Bimo, I have
Yep.
a student, Bridget. Bridget is asking that the whole idea is that to do it like this, to do the orientation like this, is so that we can print it out using a 3D printer and then create, right? So the whole idea is to combine the 3D with the concept of origami and to form the plane.
Okay, it's actually not for 3D printed. We will somehow create a layout, right, for the Depron sheet. So, okay, let me somehow finish this. It's finished already,
sure.
Right? So if you have, let's say, a Depron sheet consists of 840, sorry, 52, 840, right, like that. So this will somehow be printed in using plotter or big size printer, right? So once you place it here and it got printed, okay. So this particular, the whole sheet will somehow be printed and then placed on top of the sheet. And the lines will somehow be our guidance, okay, to cut the Depron sheet, okay. The dashed lines will somehow be lines that we need somehow to score, not cut through, okay. So this, okay, let me get back to this. Okay. Okay. These are actually the very flat Depron sheets, right? So prior to this, hang on, we have plans printed on paper and then glue it on top of the Depron sheet, on top of this, right? On top of the Depron sheet. So the solid line will somehow be our guidance to cut through the Depron sheet, but the dashed lines will somehow need to have type placed below the score line. Okay, so we will somehow break it. It will somehow stay there, and then we could simply fold it like this. I don't know whether it's clear for you guys all to see, right? But all these this particular sheet carries several score lines, right? Score cards here. So it can somehow be folded to this. So it's not for 3D printing. I haven't somehow moved into 3D printing for public release yet, but we already have sort of some designs like tilting motors, right? So it could somehow be performing vertical takeoff or vertical landing. So the wing carries two motors at its end, right? So the tilt will somehow require 3D printing objects. So it will support the structures and everything else for it to be very, very rigid. But for this design, this particular design is actually for cutting the Depron sheets, not for printing objects with 3D printers. So does it answer the question, John?
Yeah, I think the student said it's basically like making a template.
Exactly. A template pattern for us to guide us actually to cut the Depron sheet.
I see.
Okay. So basically, those are the things that somehow needed. Those are the steps needed to actually turn this plane. Okay, let me have a very, very good example with this wing. So I just simply copied it, right? It is actually a very good one, like this. And you see that it carries different shape because it's Depron sheet. It's very thin, a thin layer of Depron sheet. We could somehow shape it the way we want, right? So with a small, pretty much small curvy shapes, we can just simply do that, okay? So how do we somehow put this into a template as a template? Select this, explode, select one surface, right? Surface tools, again, unroll it, okay? There you go. So it's very, very flat. And another process, extracting the wireframe like this. Okay, hang on. Okay, okay. So I just need to remove this, 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 and this. Oh, this one. Okay. So that's the template for the wing, right? So it's pretty straightforward. It's pretty easy, right? But it requires you or requires us to actually address the approach to actually design a very smooth fuselage from this flat Depron sheets. So this is actually the score and fold approach to actually design an RC plane, right? Different approach applies to much larger, like about 2 or 3 meters wide wingspan, military surveillance aerial platform I designed, right? But mostly it could somehow be, I don't know, probably be enough for us to begin with the journey of designing RC planes or other objects or other flying objects. So these are sort of the steps to create score and fold RC planes today. And we believe that we at Pathflyers International is the only one who actually apply digital simulation on it before we actually publicly release the design, right, using the open foam. So every single planes released after 2016, right, we haven't got any failure yet because we addressed any sort of adjustments before the plan is created. So it speeds up the process, the time to actually the time needed to actually design a plane from a common 3 months designing a plane by Dave Powers or Jay Raphael or probably Stefan Moran. It took us about the fastest time we designed a plane was actually about 1 hour and 15 minutes. Just from 3 months to 1 hour and 15 minutes. That's a huge cut down time cut down in designing RC planes. Let me get back to the slides again. Yeah. Okay. Oops, sorry. That's the wrong button. Okay, any other questions, John?
I have one student who mentioned that he used to be into fixing wing RC as a hobby. So then he moved
Awesome.
then he moved to multi-rotors because of no space. I'm not really sure what multi-rotors means.
It's drones. It's drones.
Yeah.
That's
So,
awesome. So what's the
yeah.
question?
What's your advice to this student who is?
Okay, if the student actually had come to a point where he actually flying wings, right? Okay, why I chose flying wing? Because it flies much longer time than a drone. Okay, the longest time for my platform to fly was about nearly 3 hours. So it was flying autonomously, right, with autopilot and all computers installed in it, and it was a actually it was an endurance test, and it fly about 2 hours, about 53 or 54 minutes, if I'm not mistaken. So no drones, no multi-rotor platform can do more than an hour flight time at the moment. So this is what excites me very well, because we can do experiments with much lighter weight of the RC planes and turn them into a surveillance plane, right? Put many more components like such as computer for autopilot and wind speed detector with pitot and GPS, as well as cameras, multiple cameras. So we have many options to actually experiment with this fixed wing aerial platform, John.
I see. The student commented that this topic is quite fun for him.
Ah, thank you.
And maybe you inspired him to get into the RC hobby as well.
Awesome.
Yeah.
Okay.
Our 3D students are using 3D Max, and yeah. So is it quite similar? I myself am not a 3D person, but are they able to use that as well? Is it able to do what you just did just now, the template?
Okay, that's an interesting question, because I introduced 3ds Max the first time here in Indonesia. So I was the first user of 3ds Max because Autodesk gave me the software, right? But a friend of mine here in Jakarta uses 3ds Max to actually design a plane, right? But it took sort of since it's not an engineering software, right? We need somehow to look for sort of a workaround if we would like somehow to achieve something in 3ds Max. Yeah, especially the dimensions, right? In Rhino, it's easy actually to change dimensions here and there, but in Max, mostly you do it visually. Okay, but
Right.
living proof, my friend uses 3ds Max to actually design RC plane, but it's not the approach that I'm showing you here. It requires many sandings, it requires many cuts. So it's pretty much like building from a block of foam instead of sheet of foam, right? But yes, 3ds Max can be used to actually design RC plane, but with different approach, not with score and fold.
And the material you use, the paper, well, I call it a paper, but what is the material that you
The
pasted it on?
material is Depron. So
Saffron.
it's in some countries similar to Dapron is polyfoam with 5 or 6 millimeter thickness.
So it's lightweight.
It's very lightweight. Many people think it's fragile, but when it's constructed properly, it's very rigid. So I have a nephew, right? About a couple of years ago, on his final assignment, he proposed to design a UAV. So with my help, uh, we designed sort of a very rigid. So when it crashed, we just need somehow to just wipe the, I don't know, just sands or things. It won't break. It won't break at all. So that's where the very good and rigid structure helps the construction of this airplane. Even though from very fragile materials that we construct the plane, but with very good and very well planned structures, it will somehow be almost indestructible RC plane even when it crashes.
Okay. This is a question from me. How do you see, will it be able, can you replicate the designs for life scale, life size planes?
Okay, the shell, yes, but it will somehow require inner structure to be designed as well, because um, it's not just the shell, the outside skin, right, John? But
Mm.
the first time that I got a project for military purposes, those guys from Defense Department saw that I don't know what they saw me, um, because they they they, they straight told me that you can just do it. You can do it this, and we will somehow place the order. Sorry, we will place the order in designing surveillance platform and a target drone exclusively to you. So I did the design for just less than 2 weeks, I think. Yeah, about 10 days, 11 days. It was already completed. So
Awesome.
it is possible to actually enlarge this and build, I don't know, probably about 10 meters um, wingspan of an RC plane. Oh, that's huge, John.
And obviously, these are all unmanned planes, right? Unmanned.
Exactly. So that it's safe. It's safe for everyone.
Interesting. Okay, let me see if any of our lecturers have any questions. Miss Sujane, do you have a question for me?
Oh, we're our lecturers as well? Wow.
Yeah. Okay, she's not responding. Uh, I have a student who asked, is there a person called Peter Spripal?
Yeah,
Sorry,
Peter.
Peter Sripal, who makes very good videos documenting his builds.
Exactly. He's a genius guy with some with glasses, right? I know him.
Awesome.
Okay.
A
So
student is
any
asking,
other
Bridget,
questions? Uh-huh.
yeah, she's asking, can the Rhino program design other things besides planes? If not, which other program can design other things like 3D people, non-living objects?
Okay. If we're talking about Rhino, right?
Yep.
It's been used by many, I mean, many industries like jewelry design, um, aeronautics, aerodynamics, car, or the automotive. If I'm not mistaken, they own about hundreds of license of rhinos, right? NASA uses Rhino as well. Um, hang on. I actually gave training, particularly for cut and land and cut. Sorry, for cut and fill for land design in Kepulauan Riau. That's near Malaysia, right? So many industries could somehow take advantage of in using Rhino. So it's pretty much like a generic software, 3D software for everyone.
Okay. What is your opinion on Blender? Blender is upcoming now in the industry.
My God, I think it's the coolest 3D animation and modeling software out there. Why? Because I was introducing 3ds Max in Indonesia for the first time back in '96. So it was the first release. I played with Maya, I played with XSI, I played with many 3D softwares, Cinema 4D as well, right? But seeing Blender's latest release, oh my God, it's so unbelievable. The 2.9, it's unbelievable, John, unbelievable.
And it's free as well.
And it's free as well, yeah. I'm using it too. I'm using it to create sort of
Sujane, our lecturer, says that it's the best.
Oh my God, that's cool. That's true. That's true. I'm using it to create Unreal Engine's assets as well for virtual video productions.
Okay, cool. Maybe next time you can share with us more on Unreal.
I will. Thanks.
I understand also that you are dabbling in VR, VR and augmented reality as well.
Oh, yep. Mm-hmm.
Yeah.
But I don't know, virtual world creating, designing things actually have been my passion for, I don't know, for decades, John. So that's why I got involved in this industry.
I'm very happy that you are here today and you can share your enthusiasm and passion with our students.
The great pleasure is mine, John.
Okay, any more questions from the students before we end the session?
I might have one last slide to share.
Sure.
Is it okay?
Okay.
Okay.
All right.
Okay, hang on. Okay, this is actually has few things to do with me, right? But I'm gonna just share with you guys all, because most of the students I taught here in Indonesia, right? They love the ideas. Okay, so the ideas is actually just evolve. So you might probably don't know where it will end for you guys, right? Or what you become after you finish your schools. Okay, so this is actually five words related to me personally up until this point. First, with evolving by what? Be specific. Okay, be specific. Specific on what? This is actually get interesting in when you do things right, and you want to achieve something. Okay, and you think that you don't have very long list of achievements, right? Or probably you would like to populate things on your list, right? But try not to get confused easily before you have the list. Okay, in the plane hobby, try to do something simple like profile planes to use. You saw the SU30 SM design, and for some people it looks a bit complicated, right? So you try to design a profile planes. Look for search for the internet for profile planes, right? There are many free plans, many many designs that you can somehow simply follow, right? Once you define any specific objective or achievement that you would like somehow to go with, okay, it may look silly in the beginning, but it will teach you a lot about things in this hobby, right? It will teach you simplest things will somehow teach you about construction, aerodynamics, calculations, part selections, and etc. So just be specific on things that you like to do and start simple. Okay, the next one is actually the M word. Okay, you need somehow to, it needs to be measurable. Okay, it needs to be measurable. So your achievement, your goal needs to be measurable. For instance, each design after another, you need somehow to have at least one difference between the new design and the previous design. Why? Because it will somehow keeping up our mindset moving forward and not stay the same. Okay. I was actually get involved in this hobby back into back in 2014, right? And my design was actually the first community choice. I don't know, 17, 18, 19, sorry, 16, 17, 18, 19, 4 years in a row, 4 years in a row. So every single design we released has been the first choice or the best choice, community choice for 4 years in a row. So why? Because we need to address, we need to define that each new release will carry sort of more improvements over the previous ones. Okay, be specific, be measurable, and the next one, be attainable. So many times I mentioned to go practical, just like in the prior slides, right? When we're able to simplify things, it means that we have a clear understanding of what we do, and the possibility to it happens gets higher. The possibility to make things happen gets higher. That's an important thing. Okay, not just dreaming, dreaming, dreaming about. Okay. Once you specify, once you measure, once you attain, it needs somehow to be relevant, right? Okay, there's a question. If there was a question from a student, right, that would like that he shifted from fixed wing to drones. That's actually totally okay. Okay, why? Because probably when seeing a drone, it carries cameras, it carries speed, it carries other things that he probably didn't see on fixed wing platform, right? But every single thing that he saw on drone could somehow be implemented in the fixed wing aerial platform as well, right? So with this, okay, with this in mind, if we would like somehow to create or to design a particularly surveillance platform with fixed wing in the first time, that wouldn't somehow be possible. Start with something simple. Again, it will always come back to that point, right? Start with something simple, design it simple, place one component at a time, research, and you won't somehow be realizing that at some points you'll be able to design a surveillance platform after you actually go along with your path and do do some research with the prior experience and prior designs as well. And the final one is sorry, time-based, right? So people think about time-based that it's not somehow finishing a project within just a week, 2 or a month or 3 months, right? But every time, once you started a project, finish it, you measure it, probably it will somehow take about 4 months, right? But the next project should somehow take less than 4 months. So will it be 3 months, 2 months? That's okay. When showing that situation, reducing completion time from 4 months, 3 months, 2 months, then it automatically show you productivity. So you have become even more productive for the next projects. So these 5 Ks and 5 steps that I actually placed into every single project that I have, right, is actually and personally very, very important to me. So I don't know, should it somehow be useful for you guys, but probably you need somehow to consider about this as well. So I think that will somehow be my last slide, John. Question and answers actually has been going as well. Back to you, John.
All right, awesome. And always remember to pinpoint the center of gravity, right? So that your creation can fly.
Exactly.
Yeah. Okay. I think what you said just now was your acronym SMART was, I think, very relevant and very practical for the students, our students as well. Because being, whether you're a graphic design student or multimedia student or even interior design student, I think everything you do as a student should be applicable and should be practical, especially now, COVID-19. We are in a world where it's very different, and ideas should be socially relevant, relevant with the environment as well, and not just because design students tend to do things that are very self-indulgent and may not be so practical. So I think now there's a shift in the need, and whether it's commercial or in like in aerodynamics, ideas need to be more practical.
That's true.
And I also like what you mentioned just now. One of your points, to satisfy your own learning process at the highest level. I think that should be also a priority with students, because self-learning is something that you cannot just get from, I think, a classroom. I think students can gain much more online, and with your own motivation and your own independent learning. So I think, anything else you want to add before we close?
Actually, there are many things that I would like to share, but the time is just not enough.
There's always time for more. We will definitely get in touch again.
Okay.
But yeah, I think the students really enjoyed seeing the feedback from WhatsApp. And next time I'll make sure that they are able to comment here in the Blackboard Collaborate. I'm very impressed by what you did with the live online and the news. Is this live news? The Indy International University.
Yeah, if you could somehow see the lower part of the scrolling text, right? It's actually taken from Inti's website.
Awesome. I'll have to learn from you how you did that.
I'll teach you, no worries.
Awesome. Okay, so I will. There are no more questions, so I will end the session now. Okay, thank you so much, Mr. Bimo, and we really appreciate you spending your time with us to inspire our students.
Really appreciate
thank you so much.
Opportunity as well. I'd like to thank you, the other lecturers. Okay, and again, it's a great honor. It's a great pleasure to meet you guys here this morning. I hope somehow we could somehow meet again. I don't know, probably in the not too distant future.
Yes, definitely.
Okay.
Thank you so much.
Thank you so much, guys. Stay safe, stay healthy.
Yeah, stay safe. You as well. Take care.
Okay. Thanks, John. Thank you all.
You.
Bye. Take care. Bye.
Thank you. Bye. Okay, for the students, like I said, okay, after watching the sharing, I'll need you guys to write your reflection, just a short 50-word reflection about what you learned and what you experienced during the sharing in the Blackboard journal or blog. All right, so I guess you guys can't really respond to me right now, but no worries. You can, any questions you have for me afterwards, you can always WhatsApp me. All right, so I'll end the session now. Thank you so much for joining a session on a Saturday, and I'll see you in class. Okay, bye-bye.